So, hello students. A very good evening to all of you. And students, welcome to another live session of Eduins. So, am I audible to you? तो आज हम लाइट इस टॉपिक के बारे में डिस्कशन करेंगे. ओके? So students, do hurry and join the live session. Then we will start our live session. And dear students, you can visit our website at www.eduins.in. And you can contact us in the number 907333577. So this is our website www.eduins.in. Okay. So student, we will start our class. So this chapter is known to all of us, right? From the class 7, 8. So let's start the class. So this is our YouTube channel, Eduins CBSE. Please students do subscribe our channel. So now we have to start our study. So what at the very first, this is the first question. Okay, what makes things visible? And what is the answer? What makes things visible? So what is the answer, students? The answer is light. So during the day, sunlight illuminates our surroundings and objects become visible. So the physics behind the visibility of anything is the light reflection. So the phenomena is reflection. So there is several phenomena of light happens. Okay. So the phenomena are a reflection, refraction, diffraction, interference, polarization. So now we have to study about the reflection, and after that we will study the refraction phenomena. Okay, so this is the reflection phenomena, and the visibility of anything is the physics behind the visibility of anything is the reflection. So during the day, sunlight illuminates our surroundings and objects become visible when they reflect light in our eyes. While we can see through transparent materials because they transmit light. If they do not transmit, we can't see through it. Okay. So opaque objects block it. Opaque object. What is opaque object? That blocks the light. The object that blocks the light called opaque object. Okay. So can you give some example of opaque objects? Anyone from the comment section or anyone from you students? Can you give an example of an opaque object? So anyone? We know glass are transparent, but an example of opaque object. What is the example? Anyone? Iron sheet, or wood, paper, that all are the examples of opaque objects. So opaque objects blocks the light. Now, light is responsible for many stunning natural events such as shimmering of stars. Okay, this is refraction. Okay, the formation of the rainbows. This is also the refraction and dispersion. The formation of the rainbows are example of dispersions. And the way light bends through different mediums. Okay. Now, by observing everyday optical events, we generally conclude that light moves in straight paths. So, this is most evident when a small light source creates a distinct sharp shadow of an opaque object. In physics, this linear path is typically referred to as a ray of light. So, the ray of light is imaginary arrowhead. Okay. This is the ray of light that describes the path of the ray. Path of the light. So the ray of light describes the path of the light. So where the light ray is incident, from where the light ray bends or refracted, that is the ray diagram of light. Before that, we have to study about the reflection first. Okay, now fundamental laws of reflection. So at first we have to draw a ray diagram of reflection. Okay. Okay. At the very first we have to study about reflection. This is the incident ray. And what is incident ray? The light that hits the surface. Okay. This is the incident ray and this is the normal. And this is 90 degree apart from the surface. Their reflection happens. Okay. Where reflections occurs. Okay. Now this is the reflecting ray. Okay, this is incident ray. And this is the normal. So, the angle between the normal and the incident ray is called as the angle of incidence. So, this is the angle of incidence. And the angle between the normal and the reflecting ray, that's called the angle of reflection. And those laws are the general laws of reflection. Okay, so equal angles. The first law is coplanar rays. Okay, this is the first law. And the top one is the second law. So, what is the first law statement? Coplanar rays. The incoming ray, that's reflected ray, and the normal and imaginary line perpendicular to the surface at the point of impact. That is the definition of normal. So, the definition of normal is an imaginary line perpendicular to the surface at the point of impact. Okay. So, the point of impact is O. Okay. Let us assume that the point of impact is O. Now, O and A. This is the ON is perpendicular to the surface AB. So, ON is the normal and AB is the surface of incidence. Okay. Okay, so let us recapitulate the laws. Coplanar rays, the incoming ray, that is the incident ray. We can call it incident ray. Incident ray. Okay, so the incident ray, the reflected ray, and the normal all exist on the same flat plane. Okay, on the same flat plane. This is the very first law of reflection. And now the second law, the equal angle law. So, which angles are equal here? So, at the very first we have to read the statement. The angle at which light hits the surface, that is the definition of angle of incidence. So, the angle of incidence and the angle of reflection both are the same, both are in the same magnitude, or the both angles are same. So, the angle of incidence and the angle of reflection are same. Okay, are equal. So, angle of, so the angle of incidence is equal to the angle of reflection. This is the second law of reflection. Okay, these two are the fundamental laws which we have to remember. Okay, and students, for your information, tomorrow you will get the geography live class. Okay, from 6 p.m. Okay, there is a mistake of the time. So from 6 p.m. onwards, you will get the geography live session. Okay, so now after the laws, we have to know that introduction of spherical mirrors. We all read about the straight mirrors. But now we have to read about the spherical mirrors. So, the spherical mirrors, there are two types of spherical mirrors. So, spherical mirrors. There are two types of spherical mirrors. One is concave and another is convex. So there are two types of mirrors, spherical mirrors, one convex and another one is concave. So which one is concave and which one is convex? We have to know it first. So the reflecting surface curves inward like the hollow side of a spoon. It faces towards the center of the sphere it belongs to. That means the concave mirror is this type of mirror. So the hollow side is inside and the reflecting sides, hollow side is the reflecting sides. Okay. So there the light reflected. From there the light reflected. This is a concave mirror. So like the hollow side of a spoon. Okay. Now the convex mirror. So the reflecting surface bulges outward. So inverse of the concave mirror. So like this, in the hollow side there was the opaque space and the outside is the reflecting surface for the convex mirrors. So there is two types of spherical mirrors. One is convex and another is concave. So this is the convex mirror picture and this is the picture of concave mirror. Okay, this is the diagram. Okay. Now, after the definition, we have to know the definitions of the mirror. Okay, the every point of the mirror. At first, we have to know about the pole of the mirror. So, this is the geometric center of the reflecting surface of a spherical mirror. It is located directly on the mirror's surface. So, this is geometric center of the reflecting surface of a spherical mirror. So, for convex mirror, the geometrical center lies between the mirror. So, this is the pole for convex mirror. And for concave, this is the pole of concave mirror. So, this is the geometrical center of the reflecting surface or the middle point of the reflecting surface is called as the pole of the spherical mirror. So, for convex lens, this is the picture and the other picture is for concave mirror. Now, we have to know about center of curvature. So the definition of center of curvature, what is the definition? This is the center point of the sphere from which the mirror was cut. So this is the spherical mirror. We have to assume that we cut the mirror from a spherical surface, okay? From a sphere. So the sphere which from its cut, this is the center point of that sphere is known as center of curvature. Hello? So, the center of curvature, this is the center point of the sphere from which the mirror was cut. It is important to note that C is not actually on the mirror's surface, but it's okay, Sharthak. Okay, hello, welcome to this live session, Sharthak. Okay, now, but since in space for concave mirror, this center is in front of the reflecting side. Okay, let us draw this at first. So, for convex mirror, we have to draw the sphere from it cutted. So let us assume that is the sphere from the convex lens is convex mirror is cut. Okay. Now the center point of the sphere is known as the center of curvature. So for the convex mirror, this is the center of curvature. And for the concave mirror, this is the center of curvature. So, for a convex mirror, for a concave mirror, this is a concave mirror, the center is in front of the reflecting side. So, this is the reflecting side. We know that this is the reflecting side and the center of curvature is in front of the reflecting side. We have to remember it. It is important to know. Okay. So, the reflecting in the front of the reflecting side, the center of curvature situated for a concave mirror. But for the convex mirror, the center of curvature situated behind the surface of the reflection or reflecting side, behind the reflecting side. So the center of curvature is not situated on the mirror's surface, but it sits in a space. This is imaginary point. Okay. So for convex mirror, it is behind the reflecting surface, and for the concave mirror, this is front of the reflecting surface. Okay. This is important. Okay. It is important for analytical questions. So now, the next definitions. Radius of curvature. We read about the center of curvature. Now, radius of curvature. This is the distance from the center of the sphere to the mirror surface, the distance between the pole and the center of curvature. So, at first we have to draw two pictures. One is for concave, one is concave, and one is convex. Okay, so this is the convex mirror. So there is the coating of silver. This is convex mirror. Okay. Now this is concave mirror. Now, the center of curvature. We have to draw the center of curvature. This is the center of curvature. And for this mirror, this is the center of curvature. And we all know where the pole is situated. So the distance from the pole, so the distance of the pole from the center of curvature is called the radius of curvature and denoted with the symbol R or with the alphabet R. Okay. So this is the radius of curvature. So this is become radial because we denoted 2. So this is the radius of curvature. Okay. So the simple definition is the distance between the pole and the center of curvature is equal to R. This is the radius of curvature. So now the principal axis. So what is principal axis of a mirror, spherical mirror? So this is an imaginary horizontal straight line that runs through both Sarthak. Okay. This is an imaginary horizontal straight line that runs through both the pole and center of curvature. अगर हम एक लाइन ड्रॉ करें जो इंटरसेक्ट करे दो पॉइंट को, एक है पोल और अदर इज O और सेंटर ऑफ कर्वेचर, इन दोनों पॉइंट को अगर एक स्ट्रेट लाइन इंटरसेक्ट करता तो वो स्ट्रेट लाइन को हम कैसे डिफाइन करेंगे? उसको हम बोलेंगे कि वो है प्रिंसिपल एक्सिस, प्रिंसिपल एक्सिस or the main axis of the mirror. Okay, this is the main axis of the mirror, right? Got it? Now this is the radius of curvature and the principal axis. Now the other definitions we have to read. Now the concave mirror, when rays of light traveling parallel to the principal axis. Okay, so we have to study about principal focus. Principal focus. So, when rays of light traveling parallel to the principal axis. So, principal axis, this is the parallel line. Okay. So this is the principal axis that intersects the pole and the radius of and the center of curvature. So now for the concave mirror, at first we have to study about concave mirror. So this is a concave mirror. So this is the principal axis. Okay, when a light rays is incident parallel to the principal axis and hit a concave mirror, they reflect and converge at a single sharp point on the axis. So we have to draw two rays. Okay, now the reflected rays converge at a single point at the axis. So the single point where the rays are converged, that calls the principal focus. And here we got another idea that in the concave mirror, the parallel rays bends and converge at a single point. So this is the converging mirror. So the concave mirror called as converging mirror. Okay, so which mirror is a converging mirror? This is the concave mirror. Okay, so the bright spots in the sun burning experiment is actually a real image of sun formed at this focus. Okay, this is the converging mirror. Now the convex mirror. The principal focus, the definition of principal focus are different for two different types of mirrors. So for the concave mirror, the definition becomes that when rays of light traveling parallel to the principal axis hit a concave mirror, they reflect and converge at a single sharp point on the axis. This point is known as the principal focus. Okay, now for the convex mirror, the definition changes. Okay, so when parallel rays, so parallel with which line? The principal axis. Okay, so for convex mirror, this is the point, this is the pole, and this is the center of curvature. So when parallel incident rays are incident on the convex mirror's surface, okay, that divert outward. So that divert outwards. Okay. If you trace these reflected rays backward, because these are diverging rays, they do not intersect each other, never. So the reflected rays backward, they seem to originated from a single point. So just like this, from this single point. So this is the apparent point. Okay, this is not a Okay. Now, they seem to originated from a single point behind the mirror. This point is the principal focus for a convex mirror. So, there are two kinds of definition of principal axis, one for concave mirror and one for convex mirror. So, this is the diverging mirror because the ray diverge. And this is the converging mirror. So, this is important questions. Which mirror known as diverging mirror and which mirror known as the converging mirror. Okay. So do you have any doubt up to this slide? Anyone? So do you understand the definition of concave, definition of principal focus for concave or convex mirror? तो इसका नेक्स्ट में क्या है वो देखते हैं. चलो तो अब हम फोकल लेंथ के बारे में जानेंगे. सो फोकल लेंथ क्या है? The distance measured between the pole. So we know what is focus, principal focus. So length of the focus is known as the focal length. This is simple, okay? So at the simple terms, we can state like this: the focus, the principal focus from the pole, the distance from the pole to the principal focus is known as the focal length, F. The distance measured between the pole and the principal focus is called the focal length, that represented by lowercase letter f. F stands for focal length. Okay, so F stands for focal length. Now we have to draw the picture to understand it properly. So for this is the convex mirror. Okay, so the focal point situated, the principal focus situated at the front of the surface, reflecting surface. Okay, so let us assume that this is the focal principal focus F. This is the principal focus. This is the principal focus. So the distance measured between the pole and the principal focus is called the focal length. So this distance is known as A for the focal length. Okay, and this is for, sorry, it's situated behind because this is a convex lens. Okay, we have to draw it again. So for the convex lens, we get diverging rays, right? We are not getting the converging rays. So the diverging rays, okay, for these the principal focus situated behind the spherical surface, right? So this is the principal focus F. This is known as principal focus. Okay. And now the distance from the pole, between the pole and principal focus is called the focal length, that's denoted by the letter small f, alphabet. So this is denoted by the letter small f. Okay, the mirror's opening. Now we have to know also the concave. Okay, this is the concave mirror, and the principal focus situated at the front surface or the reflecting surface of the concave mirror. So from pole to the principal focus, the distance is the focal length. So this is the focal length for convex and concave, both convex and concave mirrors. Okay, the mirror's opening or aperture. So we have to know about the aperture. So the definition of aperture is a spherical mirror has a circular boundary. Okay, so from a sphere the mirror is cutted. Okay, now the mirror or the cutted surface. Okay, so the surface that cut, okay, this is the aperture. The spherical mirror has a circular boundary. The diameter of this circular area, essentially the width of the reflecting surface, is known as the aperture. In technical diagrams, this is often labeled as the distance between 2 points, just like this. This is known as aperture. Okay, this is known as aperture. Aperture of the mirror. Now, we have to assume that the aperture is much smaller than the overall radius of the mirror curve. That means the radius of the curvature and the aperture is smaller than the radius of the mirror's curve. Okay. Now, the relation between the focal length and the radius of curvature, we have to know this. So there is a specific mathematical relationship between the radius of curvature and the focal length. So for mirrors with small apertures, so we have to assume that the mirror small apertures, okay, the mirrors which have small apertures, so the radius is exactly double the focal length. That means the radius of curvature, is twice of focal length. So if this is focal length F, so this is R radius of curvature, R is 2 into F, twice of F, or F is half of R. So this is important to remember. Okay, so this is the relation. This means that the principal focus is located exactly halfway between the mirror's pole and the center of curvature. Okay, this is the basic idea. Do you have any doubt? This is the relation between the focal length and center of curvature. So, for today, that's all. We have to study about the image formed by the spherical mirrors. So, at the next class, we will discuss about the image formation and the type of image that formed by the spherical mirrors for the concave and for the convex mirror and uses of these kinds of mirrors. So, that's all for today, my dear students. So, do subscribe our YouTube channel Eduins CBSE to get the live sessions and the recorded classes. Okay, and thank you for watching the live session, students.